Hello students, this is Dr. Anita from Computational Intelligence Department. Today we are going to discuss about subnetting. Okay. Subnetting is the concept of dividing a very huge network into one or more subnets. Okay. We are going to discuss about two types. One is fixed length subnet mask and a variable length subnet mask. Now what is fixed length subnet mask? The range of each and every network is going to be fixed in a fixed length subnet mask. For example, let me do a subnetting a class C address which is 192.168.10.0, and let me assume that the requirement is going to be 30 hosts in each and every network. Now we are going to calculate how many valid subnets are there per subnet, and how many subnets does the subnet mask produce, what are the valid subnets, and what are the valid hosts in each subnets, and what is the broadcast address of each subnet. Now getting into the first question, the number of valid hosts can be calculated with the formula 2 power h minus 2, where h indicates the number of valid bits. So let me assume the range has to be greater than or equal to the requirements of our network is going to be 30. So the value of h is going to be 5, where 2 power 5 minus 2 or greater than or equal to 30, where 32 minus 2 which is equal to 30 valid hosts in each subnet. So the total valid subnet is going to be 8. So as we seen previously, the value of h, the valid bit, is going to be 5. So the total number of IP addresses that can be assigned for each and every subnet is nothing but 2 power h, which is nothing but 2 power 5. So totally each and every subnet can occupy 32 addresses. Subnet 1 is going to have the range from 10.0 to 10.31, which is nothing but it can have 32 IP addresses. The last address is going to be 10.31, and the subnet mask is going to be the one which has been already calculated, which is nothing but 255.255.255.224. So the range of each and every subnet is going to be 32, and we totally got 8 subnets. Okay, so this is about FLSM. So in FLSM, the range of each and every subnet is going to be fixed. Now here in network 1, it is going to be, the requirement is 100. So it is 2 power h minus 2 greater than or equal to requirement. So it is 2 power 7 minus 2 greater than or equal to 100. So totally we are going to have 126 valid hosts. So which is nothing but the converted bits is 8 minus 7 is equal to 1. So the last octet is going to take only one bit. It is going to borrow only one bit from your host octet. So the subnet mask is going to be 255.255.255.128 or /25, the number of bits, the number of ones in your subnet mask. Now for the next network, the requirement is equal to 40. The number of valid hosts is equal to 2 power h minus 2 greater than or equal to requirement, where the requirement is nothing but 40. So now we are going to take 2 power, if we make the h value as 5, it is going to give me the value as 30, but the requirement is actually 40. So let me take the next value, which is nothing but 6. 2 power 6 minus 2 is greater than or equal to 40, which is nothing but I can accommodate 62 valid hosts. So we are going to calculate the converted bits from the host portion, where 8 minus 6 is equal to 2. 6 is nothing but the value of h. 8 minus 2 is equal to 8 minus 6 is equal to 2. That is, we are going to borrow 2 bits from your host portion. So your subnet mask is going to be 255.255.192 or /26, the number of ones in your subnet mask. Now for the third network, the requirement is equal to 20. The number of valid hosts is equal to 2 power h minus 2 greater than or equal to requirement. Now let me take the value as 5, so which is nothing but going to give me the nearest valid host. What if I make the h value as 4? So it is nothing but 16 minus 2, which will give me only 14, so which is not meeting my requirement. So let me take the higher order, where it can take 2 power 5 minus 2 greater than or equal to 20, which is nothing but equal to 30 valid hosts. Now let me take the converted bits. So the converted bits is equal to 8 minus 5, where h value is 5 is equal to 3. So totally I'm going to borrow 3 bits from my host portion. So subnet mask will be 255.255.224 or /27. Now for the network 4, requirement is equal to 10. the number of valid hosts is equal to 2 power h minus 2 greater than or equal to requirement, which is nothing but the value of h is going to be 4. If I make it as 3, it will become 8 minus 2, 6 valid hosts, which is not meeting my requirement. So let me take the next order, which is nothing but 2 power 4 minus 2 greater than or equal to 10, which is nothing but 14 valid hosts. Now let me take the converted bits. Converted bits is equal to 8 minus 4 is equal to 4. 8 minus the value of h is equal to 4. Now I'm going to borrow 4 bits from my host portion. So totally it is going to have, so the subnet mask is going to be 255, 255, 255.240 or /28. Now we need to calculate the first address and the last address of each and every subnet. Subnet 1 is equal to 192.168.10.0 to the last address 192.168.10.127, since it can occupy 128 addresses. And this, as we calculated already, the subnet mask of our subnet is going to be 255, 255, 255.128. Now subnet 2, it's going to start with the next address of 10.128 and it can range till 192. Where the subnet mask is going to be 255, 255, 255.192. The third subnet, it is going to have the next IP address, the first address as 10.192 and the last address as 10.23. So the subnet mask is going to be 255, 255, 255.254. Subnet 4, it's going to be 192.168.10.224 till it is 10.239. So totally we are going to have 14 valid hosts in this network. And the subnet mask is going to be 255.255.255.240. So this is going to be the first address and the last address of each and every subnet. Since we have 4 subnet, which have the requirement of 100, 40, 20, and 10. So now what is the difference? What is the difference that we can see with the FLSM and VLSM? So in FLSM, the drawback of your FLSM is the more number of IP has been utilized. What if only a few number of hosts has been connected in the particular network? So since we can in the VLSM, the wastage of IP address can be minimized. So there is going to be the main advantage of your VLSM. So thank you.